My name is Christian. I'm the Events and Sponsorship Manager for DataBank, and we're excited to welcome you to today's webinar about how to future-proof your network with MultiCloud. We are joined by Christian Koch, Senior Director of Interconnection Product and Strategy at DataBank, and Kyle Moretta, Solution Architect at Megaport. At the end of the webinar, we'll open up to a Q&A session, so please feel free to drop any questions by clicking the Q&A icon at the bottom of your screen. Now I'll turn it over to Kyle, and we'll go ahead and get started.
Awesome. Thanks, Christian. Can you guys hear me all right? Just want to make sure doing a quick sound check. Awesome. Perfect. All right. So really to start off and kind of set the stage, I kind of want to walk through just a high level evolution of a customer's general journey to the cloud. And once they ultimately start to make that decision to move to the cloud and really starting to play around with a hybrid cloud type strategy. So in this first diagram that we have up on the screen here, right, maybe the customer is starting to play around in, say, AWS, an example. We're largely going to build out that connectivity via internet VPNs because they're fast and easy to build out and a nice way to start testing out some workloads. So in this diagram, we have both of our branch offices and our DataBank colo location as well, all tied in just via internet VPNs. Nice, fast way to get connected. And I would say, generally speaking, this is really the first step that I see most customers taking when they're kind of starting their cloud journey as it pertains to networking. And so as they start to get more serious about what workloads they're having in the cloud, maybe we're starting to move some more production workloads into AWS in this scenario. So now we're starting to introduce this concept of bringing in some private lines to interconnect our branch offices and to tie in our DataBank location over into AWS as well via AWS's private connectivity model, AWS Direct Connect. So in this model, the branch offices are still largely either going to utilize their MPLS connectivity back over to DataBank and hop on that dedicated circuit or hop on that Direct Connect circuit from DataBank to AWS, or they're going to leverage those internet VPNs. And so this becomes a time in our network strategy where we want to start thinking about how we can better future-proof our network from here. So once we start to realize, hey, our hybrid cloud strategy isn't going anywhere, we are going to have production workloads running both in colo space and inside of AWS. Now we also need a networking to support the networking underlay to support this connectivity as well. So now instead of having our branch offices connected via MPLS, now we're starting to play around with a little bit of SD-WAN and using our network as a service model to bridge in and tie in our different branch offices and our colo space to our AWS environments. And now we're largely moving away from relying on the internet and moving away from having to fare the storms of those internet VPNs over to a private, more consistent networking experience for your network connections from whether it's from your branch offices or from your colo. Now we're starting to play around with networking as a service and starting to leverage AWS direct connections and private connections where we can. And so as that transition or as that evolution continues on, what I largely see companies doing is they'll start off in one cloud, then they'll start to do more digging into other cloud providers as well, and realize that not all clouds are created equal, and some clouds are doing better at some things than other ones are as well. So now that we've implemented our network as a service into the mix here, we make it really easy to build out that private connections, not only to AWS, but to GCP as well. So now as we start to deploy workloads in multiple cloud providers, we can have a network that builds out and grows and expands as our workloads needs change. And so now we don't have to wait, or we can now function our network as we do at the speed of our business instead of at the speed of our carriers and how long it's going to take to build out all of this networking, because we're starting to leverage those network as a service concepts. And so the last kind of final transition that I really see in a customer's hybrid multi-cloud strategy in terms of maturity is the cloud to cloud networking piece as well. So now maybe a front-end application in AWS needs to start transitioning or start communicating with a back-end database inside GCP, or maybe we're doing some analytics on some workloads inside GCP and doing other front-end things inside of AWS. So now we start to introduce this way of privately connecting between our two different cloud environments over a private connection and not having to do that over the public internet. And so once we have kind of this almost, I will say, somewhat end state, right? Now that we've reached this state, now we have one pane of glass to manage all of our WAN networking, whether it's from our branch offices to the cloud providers or to our applications that sit inside a DataBank, or whether that's inside of AWS and GCP. We have this now kind of single holistic view of all of our WAN networking that we can manage and orchestrate, much more similar to how we kind of orchestrate our cloud workloads. And so I want to peel back some of the layers of those private connectivity models and some of those concepts that we just kind of talked about at a high level during the evolution journey. So in this diagram that we see here, this is largely what all of the major cloud providers' private networking offerings look like when we're connecting via service provider, right? So over here on the far left, where we have our DataBank location, customer would typically be physically cross-connected over into the service provider. Then from there, the service providers providing this layer 1, layer 2 extension over into these cloud on-ramps and cloud networks. And so because they've done all the heavy lifting of building out that physical infrastructure, all we do then is just carve out a slice of bandwidth on that existing network underlay to spin up these connection points. And so inside this diagram, this blue dotted line really kind of represents that layer 3 or the routing piece that takes place. And so whether it's Azure, AWS, or GCP, all of them, of course, do have their own nuances in terms of how to connect privately to them, but largely they all have a lot of similarities and a lot of things in common. The biggest differences that we kind of see are once we get into the different types of gateways that can be used in AWS and Azure and GCP, but largely at a fundamental level, a lot of the concepts kind of stay the same, right? So to best optimize or what we can do to optimize some of those networking concepts and how to build out some HA and resilient type networking, right? So in this diagram, what we really have here is now we've implemented that the private networking components from our DataBank location over to the cloud providers. Those internet VPNs that we initially started off with has now transitioned over into a backup. So our primary connection points are via our AWS Direct Connects, our Azure Express Routes, and our GCP Interconnects, with the failover being that internet VPN. And so this is, I would say, a fairly common practice that I see a lot of companies using this type of strategy, but ultimately it comes down to the business's level of resilience and how much performance they end up needing out of their backup circuits. So in this scenario, right, if our connection to AWS or our AWS Direct Connect circuit were to fail, we're going to automatically fail over to that VPN and still have that network connectivity. And now if those workloads can still function the same way as they can over the internet VPN, maybe this isn't a problem, right? So with our primary path being those direct connects and those express routes and those partner interconnects, those are going to allow us to create higher bandwidth, better latency and more predictable performance out of those circuits. And we're also going to realize some egress fee savings as well. So if we're pulling a lot of data down out of these cloud providers, leveraging these private connectivity models can help save us a lot of money. So once one of these circuits fails and we fail over to the internet VPN, typically the internet VPNs are going to be capped at around 1.25 gigs of throughput per VPN. And so if your applications can tolerate the storms of the internet and the variable in latency and jitter and the lower amount of throughputs over a VPN, maybe this isn't a problem. But what if we do need our secondary circuits or our backup circuits to have the same level of performance as our primary circuits? So that's when we kind of move over to this idea of using these private connections for both primary and secondary connection points. So now we don't have to rely on the internet in any form to have connectivity between our colo resources and our cloud resources. And regardless on whether a primary or secondary circuit fails, we're still going to end up achieving the same level of performance across those circuits. And so whereas with our internet VPN, if we fail over that, we're going to see a little bit more of degradation just by the inherent limitations of an internet VPN. Whereas when we have a primary and secondary using these private connections, largely the performance that you're going to see between the primary and secondary are largely going to look the same. And what's neat about this is that we could even deploy this in kind of an active-active or an active standby method. So if we want to truly leverage it as, hey, we have one primary path and one secondary path, we only ever use that secondary path in case our primary fails, totally fine. But one thing that's really neat when we implement our primary and secondary circuits all via these private connection models is that we can also ECMP and load balance between them as through. So we can actually achieve a higher level of aggregate throughput across all of these links. And then when we're ECMPing and load balancing between all of them, if one of those circuits were to fail, the other one's going to automatically already be up and already serving traffic. So it's also going to minimize the amount of downtime that you might see in a failover scenario in case one of these connection points kind of fail. So really, it just ultimately comes down to what level of performance and what kind of resiliency does a company need for their hybrid cloud, hybrid multi-cloud workloads, right? So now as we kind of progress our cloud environment and start to migrate more and more workloads and reach that kind of almost end state of building out cloud to cloud networking and building out applications that communicate across clouds, there's really only a couple ways that we will be able to connect our AWS, GCP, and Azure environments together. One of which we could always build a head-to-head VPN between these cloud providers. You are going to have to fare the storms of the internet. It's going to be less predictable latency jitter. You're going to achieve lower throughput. It's down and dirty, and you can get it up and running fairly quickly when we build out a cloud to cloud, just using a head-to-head VPN between, say, AWS and GCP. Another option that we could do, and well, I guess I'll backtrack to the internet VPN. So when we're using the internet VPN, also we're starting to experience some of those higher egress fees as well. So typically these cloud service providers kind of across the board charge around 9 or 10 cents per gig on any data that leaves the internet or an internet VPN. So that's another kind of benefit of using these private connections. And so the other option outside of a VPN is we can hairpin that traffic. We can build out the peering arrangements from our on-prem router between AWS, GCP, and Azure, and we can make that routing decision locally on our on-prem router. So our on-prem router is having to manage multiple peers, but is fully capable of doing the cloud-to-cloud routing themselves. Now, the issue that we run into when we kind of have that hairpin setup is it does function, but we're starting to experience some higher latency in there. So if we have a really chatty application or an application that's very latency sensitive across our AWS, GCP, or Azure environments that's communicating between the two, latency is going to be a factor for us to consider for that networking that we have in place. So when we introduce this concept of what we call a Megaport cloud router, for example, now we're able to keep that cloud routing as close to the edge as we can. So typically, this cloud router here that we have in the middle lives inside the same colo facilities and the same facilities where we're connecting to AWS, GCP, and Azure at as well. So we're really able to use that for a low latent path between our different cloud environments. And so in this diagram, this cloud router is also acting as a single point of entry for our on-prem. So not only is it facilitating any of the cloud-to-cloud networking and the traffic that we need, but it's also acting as the single point of entry into all of the clouds. So now this on-prem router is only having to manage a single peering relationship versus managing multiple peering relationships with each cloud that it needs to communicate to. And so just different ways that we can kind of think about what we have in mind and what our evolution kind of looks like, and really kind of building out and what we can do to build out and future-proof our network by implementing some of these fundamentals earlier on in our life cycle. As things progress, it gets a little bit heavier of a lift to make these bigger network changes. So early on in the life cycle, where you can build out a network strategy that mimics that of the cloud providers, where it's elastic, easy to scale up and scale down, becomes really advantageous of us for our future plans and our future strategies. So even if we're just leveraging one cloud today, that doesn't necessarily mean you might not leverage multiple clouds in the future. So the last piece that I want to touch on, or one of the last pieces that I want to touch on, is some of the different SLAs that are also offered with these different private connections. So in the two diagrams that I have up on screen right now show the GCP 3.9's SLA and the Azure's 99.95 SLA. So one thing that's neat about Azure and kind of unique to them is that with an Azure Express Route circuit, with just buying a single Express Route circuit from Azure, you get access to both a primary and secondary circuit that you can spin up. And just by spinning those up, you achieve Azure's SLA of those 99.95 SLA. With GCP, it is a little bit more a la carte, where they don't automatically provide a primary and secondary. You have to go through and order a primary and secondary partner interconnect. But similarly, it's also very easy to spin these up when we're leveraging this network as a service type model for our private connections into the cloud providers. So GCP does also have a 4 nines SLA as well, which essentially looks double of this diagram over here on the left, but sitting inside of another metro is how that looks. And the one that I'm not going to spend a whole lot of time on is the AWS SLA. With AWS, they offer two different SLA models, a 3 nines and a 4 nines. What makes achieving AWS's SLA tough for just a lot of companies right off the bat is that it does require an enterprise support plan to be in place. So if you're a smaller or medium-sized business and don't have an enterprise support plan, you would never really be able to achieve Azure or AWS's SLA just by not having that enterprise support plan in place. So there are a few prerequisites that AWS has in order for us to ultimately end up achieving those SLAs, which makes it a little bit more difficult. But one thing that I want to touch on before I move on to the next one is when we start to use kind of this network as a service model, we make it really easy to build out HA and high availability designs without necessarily achieving these different SLAs. So maybe you don't necessarily have to achieve these SLAs to build a resilient, highly available design. And so the last one that I will talk about a little bit before I pass it over to Christian is all the different locations where you would be able to pick up Megaport as our network service provider in this scenario from all of these different DataBank locations across the board here. And so with that, I will pass it over to Christian.
Thanks, Kyle. Awesome presentation, really getting into the details of how cloud connectivity is evolving and how Megaport can solve customer requirements in a multi-cloud world. Let's start getting into the slides, please. All right, so I want to talk a few minutes about how you can achieve better business outcomes with interconnection. And while the cloud is part of that, there's a whole other number of requirements that we can solve for, whether it's deploying and connecting IT infrastructure across multiple data centers, accessing customers, partners, and service providers, whether in the same data center or in another data center in a metro or other market, and connectivity to applications and data in the public cloud. So what kind of outcomes are we looking to achieve with interconnection? Well, reducing latency and increasing network performance, increasing the reliability of your connectivity, reinforcing security and lowering risk, boosting network capacity as you dedicate different amounts of capacity, whether it's through virtual connections or physical connections to different customers, partners, and service providers. It allows you to achieve greater control. And the last one, really improving visibility. Where's your traffic going? Once you start carving out and segmenting network traffic, whether it's to Google, AWS, a service provider, you get improved visibility to understand where that traffic is really going. Next slide. And how do we do this, and how do we solve for these requirements at DataBank? So here's a look at our interconnection solutions today, which we're continuing to evolve. Cross connects are dedicated and physical connectivity between customers inside the data center. Metro connectivity takes that a step further and allows you to connect customers, partners, and service providers to in another DataBank data center within the metro. And there are multiple types of connectivity options available there, whether it's DWDM, Ethernet, or physical connectivity, whether it's fiber, depending on the distance. National connectivity allows you to connect to other DataBank data centers in other markets. Whether you have a data center presence in Dallas and maybe one in Kansas City, we can allow you to connect through an Ethernet option between those data centers. And the last one is internet access. So dedicated internet access through a premium blend of ISP partners, as well as access to internet exchanges. And so, with all this, we also have a growing ecosystem of service providers, customers, and partners, to connect as your business demands. And there's a small sample of them below, but this is nowhere near the amount of providers available in our data centers today. With that said, this is very quick, and we'll leave a little bit more time for a Q&A so we can get into some of your tough questions and see how we can solve your problems.
Great. Thank you so much, Kyle and Christian. So we'll go ahead into the Q&A session. If you have any questions, please feel free to drop them either in the chat or the Q&A box at the bottom of your screen. So we did receive a question asking if this would be recorded. Yes, it will, and we will go ahead and post it on our website, and so you can share it on any of your social media. The first question that we received, I believe this is for Kyle. You talked about egress fees. Are customers afforded the egress discounted rates through your partnership with Megaport that they have negotiated to the hyperscalers?
Yeah, and that's a great question, right? So transparently speaking, so the reduced egress fees that we see with those different private connectivity models aren't a unique thing to Megaport or to DataBank. They are, each different cloud provider realizes, and I think it ultimately came down to like a business decision for them. Once they realize that customers that are leveraging these private connection models tend to leverage and utilize more resources in the cloud and more spend in the cloud, they made the business decision of, hey, it's going to be more advantageous of us to reduce the egress fees for those companies that are connecting directly to us to consume those resources, just because they tend to know that when a customer does take down these private connections and these direct connects and these express routes, that their cloud spend is also going to increase. So even if you did not go through DataBank or Megaport to get that private connection directly to AWS or Azure or GCP, you would still realize those reduced egress fees when compared to pulling data out of the cloud versus the internet or an internet VPN.
Excellent, thank you. We did have a few questions come in ahead of the webinar, so I'll read one of them that came in. What if we use IBM Cloud or Oracle Cloud as part of our hybrid strategy? Do the same principles apply?
Yes, of course, two clouds that I did not talk about. The great news is, yes, it does still apply. So even if you don't use what I like to consider the big three or the top three cloud providers, even if you do play around with, let's say IBM Cloud, OCI, Alibaba or IBM or any of those kind of more smaller plays, they all still do have private connection models that we could still leverage through a Megaport. And similarly, also those reduced egress fees largely cross the board to OCI and IBM as well too. So we could still connect privately to those resources too.
Great, thank you. Next question says, the VXC VEC charged separately besides the cost of 10 gigabyte port. So if someone subscribes for the 10 gigabytes port, will it incur additional cost for each VXC?
Yeah, that's a great question, and happy to talk a little bit more about our different pricing components in a follow-up conversation. But largely, there are the different pieces. So the physical access into Megaport would be one charge, and then any cloud connectivity to AWS or Azure would be a separate charge thereafter. But it would all be a flat rate charge. So any data that you kind of push across there, you wouldn't be paying a per gig fee from Megaport. So if you wanted to transfer petabytes of data to or from AWS to DataBank, we're not going to charge you any of those utilization fees across there.
Great, thank you. Next question that came in, can I use these private connection models to connect to public resources in the cloud like S3 or Azure Blob Storage?
Yeah, that's another great one. So of course, another thing that I didn't touch on in my slide. So when we think about, and everything that I kind of talked through was very much so speaking to private resources that sit inside of a cloud. So those resources that sit, or those VMs or those EC2 instances that sit inside of a VPC or a VNet. However, these private connection models can also be leveraged to access those public resources in the cloud, like our AWS, like DynamoDB, S3, Azure Blob, or any really of those public IP address ranges from the cloud providers. The model doesn't change all that much, but the considerations do, in the sense of we won't be able to use those RFC 1918 or those private IP address ranges to create a public peering with them. You would need to have public IPs that you could advertise to and from those different cloud providers. But yep, you could absolutely use these private connections to connect to those public resources in the cloud as well.
Great. Next question says, can I connect to service providers and other DataBank data centers with a Megaport?
That is a great question. Really, the biggest consideration for us is that other service provider has to have a Megaport connection. And so long as the service provider inside of DataBank also has a Megaport connection, let's say you need to connect to a financial institution and you're leveraging some of their resources for different financial reasons. So long as they are also a Megaport customer, we can connect any of our customers together throughout any of those DataBank locations, just because we've done that heavy lifting of building out that network. But yeah, you could absolutely connect to other third-party providers as well.
Beautiful. Last question I have says, will Megaport be available in any other DataBank data centers in the future?
Yes. So with us, we're always kind of growing and expanding our presence. And so a lot of the times it comes down to the customer demand and the customer drive out of each given location. So if there's a DataBank location that Megaport is not physically in, so long as there's a business justification for us to do it, or enough customers saying, hey, we'd love to leverage Megaport services from a DataBank location you guys aren't in, we can always evaluate that and work to get popped and get deployed into those different data centers.
Awesome. Thank you so much. Are there any other questions that we have? We still have a good amount of time, so please feel free to drop them in the chat or the Q&A. All righty. If there are no other questions, we have some contact information. So if you have any additional questions, please feel free. You can reach out to us at DataBank, events@databank.com, or contact Megaport. You can contact Matt Calloway at megaport.com. Always make sure to follow us on social media to see what webinars or events might be coming up. And like I said, we will be recording this webinar and we will have it available on our website, and Megaport, I believe you'll have it available on your website as well.
I believe so. Yeah, that sounds accurate to me, Christian.
Great. Thanks so much. All right. Well, if there are no other questions, then we will go ahead and conclude the webinar. Thank you again so much to Kyle and Christian, Megaport, and everyone for joining us today. Again, please feel free to look out for upcoming events and webinars, and enjoy the rest of your day. Thanks
Awesome.
so much.
Thanks all.